And this is a very confusing problem, so we're going to try to organize this nicely. But basically, we're given this a life table with these decrements, and Q prime of 60 decrement W was calculated incorrectly, and it should have been 0.05. So we want to find the correct value for number of withdrawals at age 60. Okay, so this is what we're going to do. First, we're going to calculate Q prime 60 decrement D. So this was actually calculated correctly. Okay, so what does that mean? Basically, we can use a table to find it. Even though the table is wrong because Q prime 60 for decrement withdrawal was incorrect, so we can still find the correct value using the table for Q prime 60 for decrement death. So that part's, again, very confusing. Okay, so the second thing we're going to do is, from there, we know Q prime 60 withdrawal. So then we would also know Q prime 60 death. So we can find the total probability of surviving age 60, which would just be P prime 60 and then P prime 60 again for both decrements. And then we can find Q60 for decrement W, because the problem is the formula depends on the total probability. So that's why we need to calculate steps 1 and 2 before we can go to 3. And then finally we can find the number of deaths. So this step is very simple. We just take L of 60 and multiply it by the probability that we withdraw at age 60. Okay. Alright, so that's the steps that we're going to be taking. Okay, so let's start with the first thing. Well, we're going to use P prime 60 for decrement death is this formula. And the reason I'm using this formula is because we have uniformly distributed over multiple decrement table. So this is the formula. Okay, so the total probability of surviving, well, we can just use a table. That's L61 over L60. And instead of writing the probability of dying over the total probability, we could just say the number of deaths over the total decrements, so withdrawing and dying. So we can rewrite it like that. Okay, so again, we're going to use a table. For the people dying is 2,580, and for the total decrements, it's still going to be 2,580. We have to add the withdrawals, which is 94,742. So when we do that, let's see, we get 0.997139. Okay, so now the second step was to find the total probability. So we're going to take both decrements and multiply the probabilities. So we just found the death one to be 0.997139. And the P prime 60 decrement W, that one was corrected. So it's 1 minus 0.05. And so for that, we'll just leave it like this. So, or actually, we'll just write like this, 0.95. Okay. So this is the total probability of surviving. Okay, so the next step is find the probability of withdrawing. So for that, we're going to use this formula. It's basically the formula we used in the first step, but we're just solving for the withdrawal. Okay, so let's see. We don't know the withdrawal, probability of withdrawing. We do know the probability of not surviving. That's 1 minus what we just found in the previous problem. So this thing over here. So it's 1 minus 0.997139 times 0.95. We have ln p prime 60 decrement w. Well, that one, let's see. That one was given. The corrected was 0.95. And so the ln of total probability of surviving, we can just look at it above. So plug it in and we get 0.49929. Okay, so we're almost there. Now we want to find the number of withdrawals. So that's D60 then decrement W. So that's just going to be how many, the probability of withdrawing, multiplying that by age 60, number of lives at age 60. So that's 0.049929 multiplied by 950,000. And so we get a total of 47,433.